Alright guys, so here's Friday's video. So graphing quadratic functions. So you're going to graph quadratic functions. You're also going to find key features of parabolas, which we're going to talk about. So what is the most important thing to know when graphing quadratic functions? That's what you should figure out when you're done with this. Alright, so quadratic function is a function whose greatest exponent is 2. Axis of symmetry is a vertical line, very key there, that cuts a parabola into two congruent parts. It is also the x-coordinate of the vertex. The vertex is the bottom or top of a parabola, so the lowest or highest point. Y-intercept is the point where the parabola intersects the y-axis, and the minimum or maximum value is the y-intercept, or sorry, y-value, y-coordinate of the vertex. So we want to graph a parabola using a table. So we're going to graph this. We're going to put this in our calculator. So that's going to go into the calculator. Alright, so we don't need this anymore. So tab, we have 2x squared minus 4x plus 3. Alright, so there's our graph. So we're going to use a table. So Control T brings up the table. So what I want to look for is I want to look for where things repeat. So if I go up, whoa, too far. Let's come back down. So do you see right here we have 3, 1, 3. So that means that's my vertex. So we want to definitely use that. So x, y, so in this case, I'm going to use 0, 3, 1, 1, and 2, 3 to graph this, because this is my vertex. You always want to use the vertex when graphing. Alright, so 0, 1, 2, 3, 1, 1, and 2, 1, 2, 3. And so close to, I didn't quite hit it, but you get the point. Now, what is the most important part is that all parabolas have what we call an axis of symmetry. Axis of symmetry, which means it cuts into two parts. So the key to this is that it's symmetric. There's one unit here, one unit there. Right? So that question, what is the most important thing to know when graphing quadratic functions? That it's symmetric, because that will allow you to find other points as needed. Alright, so we're going to kind of go over that with the next example. So we want to graph a parabola using key features. So we want to find the y-intercept, the axis of symmetry, and the vertex. Alright, so we have f of x equals negative x squared plus 4x minus 3. I'll tell you right now, this part right here is the y-intercept. So my y-intercept in a parabola is that last number, which is negative 3. So I already know that, so I'm going to put that one on here. Alright, so axis of symmetry, to find the axis of symmetry, it is negative b over 2a. So there's a 1 here, which is my a, that's my b, that's my c. So to find the axis of symmetry, which I'm going to call axosim, or sometimes I'll abbreviate it as AOS, axis of symmetry, is negative b, which is 4, over 2 times a, which is negative 1. So that's negative 4 over negative 2, or 2. So my axis of symmetry is at 2. So I have a vertical line at 2 that goes down right here. So like we said, it's symmetric, right? So this point is 1, 2 from this, so I should be able to go 1, 2 and get another point. Now I need that vertex. Remember, this is the x-coordinate of the vertex. So I know my vertex is 2, something. So I need to find that something. So I'm going to take 2, I'm going to substitute it in for x. So we have negative 2 squared plus 4 times 2 minus 3. You could put this in the calculator if you want. I'm going to do it real quick by hand. So that's negative 2 squared is 4 plus 4 times 2 is 8 minus 3. So 8 minus 4 is 4, minus 3 is 1. So my vertex is at 2, 1. So 2, 1 is here. So that means my parabola in this case opens down. And I could tell you that was going to be the case because of this negative out in front. That negative means it opens down. So that means also, with what we're going to talk about next, that is a maximum point. The one that we had in example 2, or sorry, the first example, right here, that one there was a minimum. Alright, so let's go over one more. Alright, so minimum or maximum value. So determine if each quadratic has a minimum or maximum value and find the value. So that negative there tells me that it's got a minimum. Alright? Since that is positive, this one here, that tells me it's got a maximum. So now we need to find the value. So we have to find x first. So remember, that's A, that's B, that's C. That's A, that's B, that's C. So we use negative B over 2A. So negative 12 over 2 times negative 4. So that's negative 12 over negative 8. 8 doesn't go into 12, but it reduces to 3 halves. So this is going to reduce to 3 halves. Alright, so if you don't know how to use this there, that's fine. We can use the calculator. So it's negative 4 times 3 halves squared plus 12 times 3 halves plus 18. Do not, I repeat, do not just do this one by hand. We're going to go here. We have negative 4 inside parentheses. We want 3 divided by 2 squared plus 12 inside parentheses. 3 divided by 2 plus 18. That gives me 27. So my x is 27, or sorry, my y is 27. So this is my max or my minimum value. So over here, we know it has a maximum. So that's negative b, or negative of a negative 24, which we'll talk about, over 2 times 4. That there becomes positive. So it's positive 24 over 2 times 4, which is 8. Well, 24 divided by 8 is 3. So we're going to take 3 and put it in for x. So 4 times 3 squared minus 24 times 3 plus 11. Alright, so again, we're going to come over here. 4 inside parentheses is 3. We want to square that. Minus 24, 3 plus 11 gives me negative 24, or negative 25. So that is my, in this case, maximum value. So my minimum was 27 here, my maximum was negative 25. That's how you do it. You find the x by using the axis of symmetry, then you substitute in and find the y.